A series circuit shown in the figure has a 24-volt battery that delivers a current of 1.5 amps. If R1 is equal to 3.4 ohms and R3 is equal to 6.2 ohms, calculate the ohmic value of R2. What we'll need to do first is to calculate the individual voltage drops of each resistors in the circuit. Why? Because from what we know, the sum of its voltages will equal to 24 volts. Therefore, we can subtract the voltages of R1 plus R3 from the total voltage to get the voltage of R2. And since we know that the current flowing through the circuit is 1.5 amps, by that we can solve for the value of R2, okay? For voltage 1, V1 is equal to I1 times R1. So that's 1.5 times 3.4, and this will give us 5.1 volts. For voltage 3, the same formula, V3, is equal to I3 times R3. So 1.5 times 6.2, this is 9.3 volts. Mathematically, the voltage equation will look like this. Total voltage is equal to V1 plus V2 plus V3. And since what we're looking for is V2, we can rearrange the formula so it'll look like this. V2 is equal to total voltage minus V1 minus V3. So that's 24 minus 5.1 minus 9.3, a total of 9.6 volts. Now that we know the voltage drop in this resistor, we can now identify its value. So R2 is equal to V2 over I2, 9.6 over 1.5, and this will give us 6.4 ohms.